Okay, first we're going to start with a bit of review. And let's look at multiplication. When we multiplied, if I were to have how could I set that up in my table? How could I set that up on my table? Come on up. Do it. Here, I'll slide it down for you. There you go.
The 1 and your 6 and the 10th. And you just put your 5 off to the side and...
Okay, so when you start multiplying, where do you begin? In the first number or the last number?
You get in the last number.
Okay, the last number. So you want to multiply it out?
And since it has 2 digits and the magic number is 10, you carry your 3 up to the 1. And and 3 times 5 is 15, so you add 3 to 15, which is 18. You pick your 1 to 10.
Okay, good. So your answer is, everybody, what would your answer be? 18. Now remember, the rule was if there's a number behind the decimal, then you should have a number behind the decimal, right? In this case, do we still have a number behind the decimal? Yeah, you take the answer you already have. Because if I were to just multiply this out, I would have had the number 180. And I see, in this case, I have one number behind the decimal. And so I would have to have one number behind the decimal, even though it's a 0. You wouldn't get rid of that until you put your decimal in. So what's the opposite? I wonder what this is. There we go. Okay, what's the opposite of multiplication? Division. So when we multiplied, I could have added. Let me see here. See if I can do this. You know, that's just going to have to work. Maybe. There we go. But now I've lost my line. I'll just add to it. So if I were to take that number, what was the number again? 5 times 5 times 3 6/10. Was that it? Okay, so what if I wanted to do it with pictures instead? So I start out, I have my 3. 1, 2, 3. How many would go in the tenths? How about if I move these up? That's what I'll do. Oh, the trials of placement. Okay, and then we have 6 over here. But how many times are we going to draw those dots? How many times are we going to draw those circles? Why would we do it 4 more times? What? Because we already have one set, and what are we multiplying by? What are we multiplying by?
5.
Multiplying by 5. So I already have it once, right? You know, it'd be nice if this thing would just cooperate with me. People, cooperate. Yay, it's cooperating. So I have 1, 2, 3, 4. There we go. See, if I would have used my problem-solving skills to begin with, I would have figured that out. And I'm going to do this a total of 5 times. And if I were to count up all of these, how many would I have? Does anyone know? $30? And what happens when every time we have 10, what happens? We move the number over to the ones place, because remember, we're going this way, it means that we've increased by 10. When we go this way, it means we've increased by 1/10, right? So every 10 is going to come over to my ones place. So right here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What am I going to do? Bring it over to the ones. Does it matter where I put it at this point? No, it doesn't matter where I put it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bring it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why do you think I just counted the dots before I started crossing them out?
Just to make sure you actually have 30.
To make sure I actually had enough dots, because I might have had 9 or I might have had 8, and then I would have crossed them out, and guess what? I wouldn't have known which ones I hadn't crossed out, and then I'd have started all over. But I see that I have 10 left because I double-checked. So I'm going to put another dot over here. How many 10s did we just add to the ones column? 3. We added 3 10s, which is the same as, what's 3 10s equal to? Everybody. 30. So how many do we have left in the tenths that don't have a line through them? How many do we have? 0. Bring down the decimal. And how many do I have in the ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I move it over? Yep, I have enough to move over. 1, 2, 3, 4, 5, 6, 7, 8. Do I have enough to move over? How many did I just say I had? 8. So now what do I do with the one in the tens? Is that the same answer we got earlier? Can you do it this way? So let's try the opposite. Now, if we did the opposite, that means that we would take 18 and divide it by 5, right? And that should give us 3 6/10. So I have 18. It's 110, right? We're going to divide into 5 parts. How could we do that? I have 1 in a tens place. How do you divide 1 into 5 parts? How would I do that? Think about it. Talk to your neighbor. What do you think? What did you and your partner discuss?
We thought that we divide the ones with the tens.
You divide the ones with the tens. Okay, so how would you do that? What would you do?
Divide, you would total up how much one included 10, and then you would just add up all the dots, and then when you figure a number, you would add up the 10, and then you divide it.
You add up what's in the tens? Well, right now I have 1 in the tens, but I've got to make it into 5 pieces. I've got to be able to take these dots and fill every single one of these spaces. How do I do that with just 1? Can I do that? Can I tear that 1 apart?
Well, I thought that maybe you could do, like, in the three spaces, that 1 divided into 5, so it'd be 2 tenths.
2 tenths?
And then, like, 2 tenths times 5, so like 2 times 5 is 10.
Okay, any other ideas? What do you think?
My partner thought that we would bring the 1 over to the 1 place and have 18 ones.
So you think you're going to take the 1 from the tens and have 18 ones? Could you divide 18 ones with 5? You might have a remainder, wouldn't you? But could you divide it out? Can you divide 1 into 5 parts? So if I were doing this like a multiplication problem, I'd start at the end, right, and divide it out. But division's opposite, so which part do you think I'm going to start with? The beginning. When you multiply, you start at the end and you move all the numbers to the left as you fill up each place, right? But when you divide, you're going to break it down. So you're moving all your numbers from the beginning to the place next to it. So if I take my tens, because I can't do anything, right? I'm going to get rid of that one, and I'm going to move it over. So I just add 1 to it? Do I just add 1?
You add 10.
Why would I add 10? Go ahead.
It takes 10, 1 to equal 110, so if you think about block, 10 1 is equal to 1.
Good, because it takes 10 ones to equal a 10 in the tens place, right? So if I move them over, I'm going to add 10 dots. Well, I already have 18, right? Or 8, sorry. Ten. Now, how do you think I would divide that evenly? How would I divide that evenly? Because right now I have 18. I have 18, so I'm going to erase my original 8. That looks too much like a dot. There we go. So now I have 18 in this place. How would I make sure I got it all evened out?
You can cut it in half and add 9 to 1.
You can do what?
Cut it in half, and so 18 minus 9, and you will have to divide this side and add that.
So if I cut it in half, though, that means I'd only have 2 of these places filled, right? But then what would I do with those other 3 places? How would I make sure that I had all those dots evenly distributed every single box? Move over to tenths. What do you think? One dot in each box. So if you're not looking up here right now, then I would assume you're not paying attention, and you probably need to know this. So I have 5, right? I have 1, 2, 3, 4, 5. And my goal is to fill those boxes with 18 dots, right? So this is what you do. You just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, shoot, I couldn't finish. I couldn't finish, could I? That's a problem. How many of these 18 did I just use? How many of the 18 did I just use? I used 15, so I can go up here and I can cross those out, right? Because I just used them. 8, 9, 10, 11, 12, 13, 14, 15. You know why I have that? Because I didn't erase part of that parenthesis. There we go. What am I left with? So I use these, right? This will make it easier for you to see. How many am I left with? 3. So what do you think I need to do with those 3? Move them to the tenths. So then I end up with 3 tenths. That's the way it works. If I move over 3 ones to the tenths place, how many tenths am I moving over? 3? 10? 30. Remember, for every single one, I could just do it one at a time if you're having a hard time figuring it out. Start with the first one. The first one equals how many tenths? 10. The second one equals 10. And the third one equals? Leaving me with a total of 30 in that section, right? So how am I going to divide it out? What do you think? How do I divide out? Perfect. Keep doing the dots until I run out. If that confuses you, you can just go 1. Let me cross that out and do a different color. I could just do it this way, 1. Just go up and cross them out as I go along. It's kind of a long process, isn't it? Somewhere I skipped one. Okay, how many do I have in each row in the ones? 3. Bring down a decimal. How many do I have in each row of the tenths? 6. Is 5 times 3 6/10 equal to 18? Is 18 divided by 5 equal to 3 6/10? Did we just divide out? Yes, we did. Okay, look at your book. Problem set 1A. Now, I want you to draw that table. So you're going to draw your little discs that we just did. But then I want you to also solve it long division. Now, here's also, I forgot to tell you that if we had numbers here, like if we, when we had that, how many did we have over here? 18? And we have to have a remainder. What can you always add over here? A 0. So if you have a remainder and there's not a number here, you just put a 0 up there and then you know. But if you've moved one number over, you'd move over 10, right? So I think the drawing it out is pretty easy, but long division. Can I ask you a question? Does McDonald's serve cheeseburgers? Does McDonald's serve cheeseburgers? They do. Does McDonald's serve cheeseburgers? Why would I ask you that right now when I'm about to teach you how to do long division? Why would I ask you that? Make sure you're paying attention. Those are the steps on how to divide. So everybody, what do you think the D means?
Divide, multiply, subtract.
Ooh.
Carry, check.
What are you checking? What are you checking?
Make sure, like, you multiply, like, you do division and check, so when you multiply, you do multiplication.
Okay. You check your answer to make sure that, come on in guys, just silently. You check your answer to make sure it's not bigger than the number it's going into. And then what do? What's this thing? The B. Everybody. Bring down. So we have the problem. Let's do a reminder. Does McDonald's serve cheeseburgers? And our problem that we have is what's the first thing we have to do? Everybody, first thing. Divide. What am I going to divide into? What am I going to take my 3 into? 4. Okay, so how many times does 3 go into 4? So I just divided, so I'm going to put a little check there to remind myself. Now what's my next step I have to do? What am I going to multiply? 3 times 4? Okay, you take your top number that you just entered times the outside number. which is your divisor. Okay, this is a dividend. This is the divisor. Anyone know what the answer is called? Ooh. Quotient. So 3 times 1 is 3. So I'm going to put a check. I've just done that. Now what do I do, everybody? 4 minus 3. 1. Now what do? Oops, I better put my check. Now what do? I check. This is what I'm talking about. So everybody needs to look up here so that you are well aware of what you need to do. What I'm checking to see is if this number right here is bigger than that number. Is it bigger than it?
No.
Is it equal to it? If it's smaller, that means 3 does not go into that number anymore, which means this number must be right. Because if it was 3, that means it would go in another time, wouldn't it? And that number up there would be wrong. So you're checking to see if this number right here is bigger or equal to that number. And it's not. So I think we're fairly safe. So we just checked it, didn't we? Now what are we going to do? Bring down. Bring down 236. Bring down the 2. And I'm going to check that. Now what do I need to do? I'm going to erase my check marks because I get to do what, everybody? What do you think I get to do? Start over until I run out of numbers, right? Am I going to take, when I divide this time, am I going to say how many times does 3 go into 2? Am I going to ask how many times it goes into 42? What am I going to ask myself? How many times does 3 go into 12? So, everybody, how many times does 3 go into 12? 4 times. Now what do I need to do? Everybody? Multiply. 3 times the number I just wrote up. They're not 3 times 14, but 3 times the number I just wrote up. 3 times 4 equals 12. Now what do I do? Subtract. So I'm going to subtract. Check that off. 0. Then what do I do? Check. What am I checking? To see if what?
To see if the 0 is bigger than 3.
See if the 0 is bigger than 3. Is it?
No.
I can move on, can't I? So what do I do now? Everybody. Bring down. Now what do I get to do? Start over. Divide 3 into 3. What is it? Everybody. Woo! Okay. Let me recover from my heart attack first. Okay. What is 3 divided by 3, everybody? 1. Thank you. Bless your hearts. Okay, divide. Then what do we do, everybody? Multiply 1 times. 3. And what's my answer? 3. Now what do I do? Subtract. 3 minus 3 is 0. Then what do I do? Check. Is 0 bigger than 3? No. Now what do I do? Bring down the 6. Right there. Now what do I get to do? Start over. How many times does 3 go into 6? 2 times 3? 6. Subtract. 6 minus 6 is? 0. Check it. Is 0 bigger than 3? No. Bring down. Is there anything to bring down? No. Could I add zeros to this and keep bringing down? Yeah, if I had a number here, I could always add a 0 and keep adding it. There's something I'm missing in my answer, though. What am I missing? The decimal. What do you think I do with that decimal? Everybody, tell me what you think.
Bring it up.
Ooh, you guys redeemed yourselves. Bring it up. So, 4 and 236 thousandths divided by 3 equals 1 and... And the way to check that would be to multiply. Is it always good to check your work? Yeah. What's 3 times 2? 3 times 1? 3 times 4?
12.
Carry the 1. 3 times 1?
3.
Whoops, thank you. Okay, now remember, we don't bring up or down. When we did our multiplication the other day, remember, if it had 3 numbers behind a decimal, how many numbers were behind the decimal in the answer? 3. So, 1, 2, 3. This puts 3 numbers behind a decimal. Does my product match my dividend? That's how you check to make sure you're 100% right. You know, learning these steps is the best thing that you can do for yourself, and learning how to double check yourself, because you'll always get 100%. Okay? If you don't take time to check, or you don't take time to write it out, you won't get the grade. You get the grade of how much effort you're willing to put into it.